we're going to talk about complex rational expressions. This is just going to be more of a summary than a full-on lesson, but it should be enough to bring back memories or at least kind of to pick up on everything. So complex rational expressions are the ones that look a little insane, but they're actually really fun. So the first thing that I would recommend doing is create one fraction in the numerator and one in the denominator if you have multiple. Rewrite the problem as division, and then simplify. The thing is that I think sometimes I rewrite as division first and then create the fractions. But I do understand why a lot of people suggest this way, so we're gonna go with that way. Also, yes, I sliced my finger this morning, so if you see a band-aid and blood, you know, such is life. So I'm going to actually use two colors initially to differentiate between the numerator and denominator as we proceed. So step one is to create one fraction in the numerator and in the denominator. So that's where we are. We already have one fraction in each. So we're going to rewrite this now as a division problem. 6 over xy divided by 3, I think that's a y, 3y over 8x cubed. I guess you can't really see the difference. I'll go with one color for now. All right, now we need to switch it to multiplication because that's what we do in a division problem. Honestly, I would not really skip this step, rewriting it this way, because it's hard to switch it in your brain and be accurate all the time. So I wouldn't switch that. Now we're going to multiply. So I'm struggling. I'll tell you what I'm struggling with. I like to cross cancel, but I'm not going to do that right now. So 6 times 8 is 48, x cubed in the numerator, and then we're going to have 3xy squared in the denominator. And now we need to simplify. So 48 divided by 3, I think it's 16, but I'm going to verify. Yes. So we're going to have 16 and 1. We have x cubed and x to the first, so that's going to end up being x squared because we subtract. And the y squared doesn't have anything on top, so we're just going to keep it there in the bottom. So 16x squared over y squared. The 1, obviously, you don't need that guy. All right, so now let's look at it a little more complicated. Again, we're starting with one fraction in the numerator and one fraction in the denominator, so we're good there. We're going to rewrite this now as division. So we have b plus 2 over b squared plus 6b plus 8 divided by 1 over b squared minus b minus 20. Of course, the next step is to switch to multiplication. Our first fraction stays the same. Switch, and then flip the second fraction. And you should be able to go from there on your own. So you should be able to factor it and to continue. I will continue, but that would be a spot I would recommend pausing. The top is not factorable. The denominator is. What are the factors of 8 that add up to 6, 4, and 2? So b plus 4, b plus 2. Times the factors of negative 20 that add up to negative 1 would be b minus 5, b plus 4 over 1. Write everything in terms of multiplication. So we're going to multiply through. And I'm not going to write the 1 because, well, hopefully now you are. All right, we're going to cancel anything that we can. Any commons? So the end answer for this is just b minus 5. That's it. Not terrible. Let's look at the next one. So in this one, we do need to do that first step where we make the denominator into one fraction. A lot of the times I like to kind of pull this to the side to do it. That way I can leave my space out here. So I'm just going to kind of rewrite this out to the side while I work on it. Remember, when we're adding and subtracting, we need to have the same thing in the denominator, a common denominator. So this one is factorable, so let's go ahead and factor that. We can pull out a GCF of 4, and we do almost have a common denominator, but we are going to need to account for this 4. So I'm going to multiply this, and remember, what you do to the numerator, you do to the denominator. So we have 80 over 4 times n minus 4. I use the commutative property there. 5 minus 4 times n minus 4. We have a common denominator, so we're going to subtract. That would be 75 over 4 times n minus 4. So I'm going to put that now up here. All right, you can see now that we have single fraction over each other, and we're going to rewrite as division. We're going to change to multiplication and flip the second fraction. And I'm actually going to show you the way I really simplify in this one. You are welcome to multiply through, but I simplify like this. I know 4 divided by 4 is 1, so I can cross those off. 5 goes into 5 once, and 5 goes into 75 15 times. And now I like to multiply through. So that's going to be 1 times n minus 4 over 1 times 15. If you are confused at all about that part, feel free to actually do it the long way, which would be to do, what is that, 520 n minus 4, and then 4 times 75 over 300, and then simplify. You'll get the same answer, but I like to do it this way as often as I can. All right, one more example. We have in the numerator and denominator fraction, so I'm going to kind of pull those off to the side also. I'm going to do the denominator down here. We have a over a plus 3 plus 1/5. We need a common denominator, so I'm going to multiply this fraction by 5, and I'm going to multiply this fraction by a plus 3. Remember, numerator and denominator get multiplied by the same thing. So we have 5a over 5 times a plus 3 plus a plus 3 over 5 times a plus 3. We're going to add 5a plus 3 all over the common denominator. And we're going to combine like terms. And that's going to be our denominator. Now we're going to do the numerator. I don't even know where I want to do that. I'm just going to kind of do it up. Let me draw a thing between. Okay. I'm going to do the numerator up here. So a squared over a plus 3 plus a squared over, and I'm actually going to go ahead and factor this by taking the 5 like that, just so I'm kind of completing one step as I rewrite. We need to make these a common denominator, so think about what that means. Hopefully you thought about multiplying the first one all by 5. So we have 5a squared over the common denominator plus a squared. Okay, I can see that that's going to be 6a squared over 5 times a plus 3. All right, that part is a little bit confusing sometimes, so if you don't follow what I did, please let me know. We're going to rewrite this now as a division problem. And now as multiplication by keeping the first the same and flipping the second. All right, I'm gonna go ahead and factor the bottom of this one. Oops, GCF of 3, like that. And I'm gonna multiply through, but actually, now that I'm looking at it, I think what I really want to do is redistribute this numerator. Do I? No, I don't want to do that. All right. So I was thinking about adding for a second, I don't know. So now we're gonna multiply. 6 times 5 is 30, a squared, and a plus 3. And in the denominator, we have 5 times 3 is 15, a plus 3, and a plus 1. Any questions? If you have them, please let me know. Now we're going to go through and simplify. We can cross off our a plus 3's. 30 and 15 would become 2. So we have 2a squared left in the numerator and just a plus 1 in the denominator. So that is how you do complex rational expressions. I think they're kind of fun, and I hope you have a good day.